Welcome back to PLS 510. We're going to continue on the topic of understanding forage quality uh, by looking or starting with understanding forage quality reports. So we've talked about forage quality in general in part one. This is part two. I want to bring your attention to two publications that are especially good if you want to read more about this topic. And I consider this publication, Understanding Forage Quality by Don Ball and others, to be the best there is in terms of the topic of forage quality. The Kentucky version that is simplified is ID 101, Interpreting Forage Quality Reports. And that is also a good publication with a little age on it now that we need to redo. I want to point out, and we're going to take a look at both a simple and a complex report. We'll spend more time on the complex report either now or later, but this is a Department of Ag report, and you can see that we've got things like relative feed value, RFV, protein, the fiber parameters, moisture, dry matter, TDN, and so on, minerals, and then some comments down here that help identify the forage. Here's a more complex report from Dairy One. This one happens to be a silage or a baleage report. And so you're going to have quality parameters in this upper part of the report, and you're going to have the fermentation results down here at the bottom of the report. But we're going to go into some detail, so just stay tuned. To understand forage reports, we got to understand this relationship between fiber and energy. High fiber, low energy, that's shredded wheat. You don't have a very how much would it take to fill up to meet your daily energy needs? Quite a bit. Would you be able to eat that much? Maybe not. You'd be too full. On the other hand, a low fiber, high energy feed or food like Breyer's ice cream has low fiber and very high energy. You'd easily be able to meet your energy needs because this is not going to fill you up. This is exactly the same comparison or analogy between high fiber, low quality forages and low fiber, high quality forages. And remember, as forages mature and they go from leafy to bloom, then we're looking at the fiber goes up and the energy, the fiber here represented by this dotted line and the solid line for fiber, lignin similarly. Then you got protein and leaves and minerals going down in concentration as the forage gets more mature. And of course, quality and yield move in different directions, and fiber and energy move in opposite directions. Why two columns? The as received, or the as fed, sometimes is what it is called, column is where the components are calculated based on the fresh weight when received by the lab. So it makes these calculations with the moisture content as part of it. We seldom use the as received values except if measuring out fresh forage for a ration, or you're trying to weigh hay and bring it to an animal. The dry matter basis or column, or the dry matter column, is the one we typically use to evaluate quality because we don't have to make adjustments for the differing moisture content in different samples. Here are the terms that you may find on a forage report: and dry matter, moisture, crude protein, and we call it crude because it's percent nitrogen times 6.25, acid detergent fiber, ADF, neutral detergent fiber, and sometimes this NDF is preceded by a small a. That A stands for amylose treatment or amylase treatment. Then the NDF-D, which is neutral detergent fiber digestibility. Acid detergent fiber nitrogen, sometimes you find that. You find minerals. The total minerals are the ash, or you may find them listed individually. You can then find TDN, the net energy, the digestible energy, relative feed value, and then RFQ, relative forage quality. And then if we're talking about baleage, we're going to talk about pH and volatile fatty acids. Some of the parameters on a forage report are measured, but others are calculated. The measured ones: moisture or dry matter, nitrogen, from which we get crude protein, fiber, ADF, NDF, fiber digestibility, minerals, and in the silage, you can see the ones that we're measuring. We calculate, on the other hand, total digestible nutrients and any energy value like net energy or digestible energy for horses, relative feed value, and then scratch this, it should say relative forage quality, RFQ. So let's walk through several of these parameters, starting with crude protein. And as I said, it's called crude protein because we don't measure it directly but calculate it from percent N. So it's an estimate of real protein calculated by multiplying percent N times 6.25. It combines the real protein and non-protein nitrogen, like nitrates, for example. Forage diets are going to be limited by energy way before they are limited by protein. And so protein, though, can contribute to problems in the insulin-resistant horse in that it stimulates an insulin response in the horse. So you just hang on to that. We'll talk about that a little bit later. Neutral detergent fiber, NDF. NDF is a combination of cellulose, hemicellulose, and lignin plus ash. It's used to estimate intake. Low NDF numbers are desired. Low NDF numbers indicate livestock can consume more of a forage. Low NDF numbers come from less mature forages. And an equation that everybody has agreed on for ruminants is that dry matter intake is going to be equal to 120 divided by the NDF. If the NDF, like for this sample on the left, is approximately 60, that's 58.7, then the dry matter intake, the estimated dry matter intake that a cow will be able to eat on a percent of body weight basis is just a little over 2%. NDFD, it's the proportion of neutral detergent fiber lost during incubation with rumen fluid, and you may specify shorter or longer periods of incubation. It's a measure of the digestibility of the cell wall. It's important for calculating rations for high-producing livestock and for calculating relative forage quality, RFQ. Acid detergent fiber, and I oftentimes will simplify that, or just my broad definition, oversimplified probably, is that it's the relatively indigestible fiber. It's composed of cellulose, lignin, and silica, or basically the parts of the forage, the ground forage, that's not soluble in neutral detergent fiber solution, or neutral detergent solution. We use it to calculate TDN and almost every one of the energy terms. And sometimes some equations use ADF alone, and other equations use ADF plus other things. Low ADF numbers are desired. Low ADF numbers come from less mature forages. Total digestible nutrients. I oftentimes simplify this, or to overstate my case here, that the most important value on the report for a ruminant is the total digestible nutrient line, TDN. Why? Well, really the comparison I'm making here is to help them understand that protein is important, but protein is seldom the most limiting factor. So in this case, TDN, and TDN is not underlined in this slide. It's right here. It should be right here at the TDN estimated here at 50.41. So TDN is a calculated estimate of the digestibility or energy content of a forage. TDN goes down as ADF goes up, or when the forages become more mature, and TDN is the most important, or is more important, because energy is the most limiting nutrient in forage diets of ruminants. TDN is analogous to digestible energy, or DE, for horses. One of the confusing things, and it's really a problem in the forage world, if you really want to drill down into this forage testing and energy prediction situation, is that every lab will tend to have their own individual equation for predicting TDN, or total digestible nutrients. Take this top one, for example, by Agri-Food Laboratories. It's based completely off of ADF. If you want to look at Arkansas's data, the University of Arkansas, the ones they use, it uses protein and ADF. Cumberland Valley uses an even more complex equation using several things that you may recognize: LIG for lignin, acid detergent, insoluble nitrogen, and so on. And there's the Kentucky Department of Agriculture using just ADF. Here are a couple more with just ADF, and then anyway, you can see the point here. Now, the good news is that all of these for the same forage will generate fairly similar TDN values. But if you're trying to compare from one lab to another, then you need to know that if you've got an ADF of 30, you may wind up with a different TDN when you send samples to two different labs. Now, RFV, relative feed value, is a index of quality for comparing similar forages. Now, it's based, and they came up with this index by estimating digestibility and estimating intake. Those calculations of digestibility and intake come from ADF for digestibility, NDF for intake, and of course, the higher the RFV, the better the quality. The RFV of full bloom alfalfa has been set to 100 by using a factor in there, so that we can have an index point and a point of reference. RFV is getting to be well understood by producers, but we have a big limitation, and this is very important. The limitation of RFV, relative feed value, is that it's only valid for comparing similar forages, such as a group of alfalfa hays or a group of grass hays. This goes into the detail here with the RFV calculations, and then I'll let you just take a look at that on your own time. That's just for your information. Relative forage quality, RFQ, and there is a reading assignment that you should have on RFV versus RFQ. RFQ is Simply Better by Mike Rankin. And you can see that RFQ is a TDN times DMI, dry matter intake, with a fudge factor in it. It's an improvement over RFV. It uses a summative TDN equation for digestible dry matter, DDM. And that summative equation means you take the sum of the digestibility of each forage component rather than calculate the TDN from ADF alone. It better accounts for the differences in forage digestibility in that it uses NDFD and not NDFCP, crude protein, to estimate, to calculate DMI and also the energy. So this is a true one number quality index to compare different forages. So you can compare a grass to a legume. So this is what we are moving to in terms of comparison of dissimilar forages. This is a set of hays, 23 of them to be exact, that were in the 2021 Hardin County, Kentucky Hay Contest. And RFQ is in the gold and RFV is in the blue. And you can see that these are nearly every case, the RFQ is quite a bit higher than the RFV. Whoops, pardon me. And this means these are most likely grass hays. And you can see, like, for example, this one, number 23, which was a very, very good hay, and the RFQ would be almost 200. This one, let's see, number 4, you've got those being similar. I'd bet you that that's primarily a legume hay, in which case most of the time the RFVs and RFQs are pretty similar in value. But my point is that RFQ is going to give you a different index, but we can use it then to compare forages in terms of their forage value, but even if they're not similar types. Now, if we were in person, I'd have you stand up, stretch, roll your shoulders, and and to refresh yourself. And if you're watching this online, then I'd have you do it anyway, because we're about to dive into something and it's just going to feel like math. Okay, so just sit back, relax, stand up, take a break, whatever you got to do. We're going to talk about the carbohydrates section of this report, and this is highlighted in red, pulled off to the left here. So we're going to take a deep dive. All right, here are the terms we're going to be looking at. NFC, this is a Dairy 1 report. That's non-fiber carbs. We're going to look at starch. We're going to look at water-soluble carbs. We're going to look at ethanol-soluble carbs, ESC. All right, let's define them. NFC, non-fiber carbs. Carbs not in the NDF. It includes starch, water-soluble carbs, and by the way, ethanol-soluble carbs, ESC, is a subset of water-soluble carbs. So in this case, we don't need to add both of those. We just need to add the water-soluble carbs. It contains ESC. The pectins and complex long-chain carbs. So we determine NFC by difference. It's 100 minus the protein, minus the NDF, minus the ash, and that would then give us this NFC number. Non-structural carbohydrates, that's not on the report, but it is referred to by horse nutritionists, and it's equal to starch plus water-soluble carbs. This is the fraction of the carbs that is readily digested in the foregut of the horse, targeted to be less than 10 for the metabolic horse. So if I ask you, and I will, what is the non-structural carbohydrate value for this particular hay on the left, or in this red box, you're going to add 7.1 and 1.4 for a total of 8.5. So this case, if this is all you know, this hay is a suitable hay for the metabolic horse. Now, water-soluble carbs and ethanol-soluble carbs are exactly what they say they are, and this report goes further to say that the ESC, ethanol-soluble carbs, are simple sugars. And so there you go, WSC, water-soluble carbs, and then ESC is the subset of water-soluble carbs, and it's the simple sugars. Now, this is where, you need to screw your attention span down tight. Alfalfa looks like a low-carb hay in that it typically has low starch values and low water-soluble carbohydrate values, except the protein in alfalfa acts like a carbohydrate for the insulin-resistant horse, where it stimulates an insulin response. When we look at forages for metabolic horses, the average Kentucky first cutting of orchard grass tends to have lower NSC every single time. Mature Timothy might have lower NSC, but it certainly got high NDF, low cell contents. But early maturing Timothy can have high NSC, and this is somewhat confusing. But a mature Timothy, we can take a look at that report, and I'll show you a couple if we have a live opportunity to do some comparison there. Teff is a summer annual grass that's naturally low in non-structural carbohydrates. Now, if we're going to interpret forage quality for cattle, the simple interpretation is to take this table and then draw on the table the TDN value and the crude protein value, as I have for a hay that is 61.2% TDN and 19.2% protein. You can see that hay, if you look at the cow on the on a TDN basis, that's enough TDN to take care of everything up to the 2-year-old with average milk. The protein exceeds the needs of every classification. Almost the same situation for the steer. except the protein doesn't quite cover the needs of the steer that's trying to gain 3 pounds a day. The TDN at 61.2 is almost enough to get 1.5 pounds of gain per day. So, and the whole point of this is saying this is a pretty simple way to tell if a hay is good or bad with cattle. And also, one more point about this, that we're more limiting with energy than we are with protein, nearly every case. And we often say that the ultimate measure of quality is the animal performance. And in the case of mature animals, that's body condition. And I want to talk about the winter of 2018-2019 and the idea that we had mature hay, we had mud, we had cold, wet conditions, and we had a lot of problems. Now I want to introduce the idea of a thermoneutral temperature and energy needs in the cow. A thermoneutral temperature is that temperature at which the temperature range at which the cow or steer doesn't need to burn off any extra internal energy to maintain its body heat. All right. For dry-hided animals, that temperature is as low as 18 degrees Fahrenheit. For wet-hided animals, that temperature jumps to 55 degrees Fahrenheit. You say, well, okay, so, well, for every 10-degree drop below that thermoneutral temperature, we have to plus up 5 percentage units. So a hay at 50% that might be good for a dry cow, all of a sudden, if she's wet-hided, she needs a 60% TDN hay, and those are two very different hays. And the problem in 2019 was that hay that had been adequate in the past was not good enough, and animals starved. And this is the point of this is that most people intuitively would like to know how their good hay tests. The most important hay to test is that hay that's on the low end of your quality spectrum, because you don't want to assume that it can meet a certain class of animals' needs like it has in the past, have a bad year like 2019, and then we have a train wreck that you did not anticipate like we did in 2019. We have a beef forage supplement tool that you just plug in the dry matter, the protein, the NDF and TDN, and the stage of lactation, and it will generate for you the need for supplementation if you have it, and how much of each particular supplement, should you choose it, it would need. So to summarize this part 2 of forage quality, a good forage test, or this is actually the summary for the whole thing, a good forage test starts with a good sample, 15 to 20 cores for each lot of hay. You send it to a reputable laboratory. Understanding forage quality means you got to understand fiber and energy and the relationship between the two. If we're going to interpret results, we need to focus on energy and crude protein, with energy being more limited, and to compare that to the nutritional needs of the animal to be fed. And carbohydrate levels are more important for metabolic or insulin-resistant horses. And as we said in the very, very, very beginning, the best measure of forage quality is the actual animal performance.